Hello everyone, welcome to my channel. Our today's topic of discussion is HCF and LCM of numbers. Okay, now these terms are quite known to all of you. What is meant by HCF? HCF means the highest common factor. Okay, that means if you consider two numbers like 10 and 15, then the HCF of these two numbers means that particular highest number which will divide each of them completely. Okay, that means leaves remainder 0. So here we get that HCF of these two numbers, if you factorize them, you will get 5 into 2 as the prime factors of 10 and 15 will be 5 into 3. So here 5 is that highest common factor which will divide both 10 and 15 completely. Now what is meant by LCM? It means the lowest common multiple, which means by LCM of two numbers we actually get that lowest or least number which is divisible by each of them completely. What does it mean? If you consider 10 and 15, their LCM will be 30. Why? If you consider the multiples of 10, you will get 10, 20, 30, 40 and so on, infinite number of multiples. If you consider the multiples of 15, you will get 15, 30, 45, 60 and so on, infinite number of multiples. So out of all these multiples, you will get 30 is the lowest common one. Okay, that means the LCM of these two numbers is 30. That means 30 is that least number, the least number which is divisible by both 10 and 15. Okay, that means all the other infinite number of numbers which are divisible by both 10 and 15 must be the multiple of 30. So among all those numbers, 30 is the lowest number. So by HCF we get the highest common factor of the numbers, and by LCM we get the lowest common multiple of the given numbers. Now let's consider a very unique property of HCF and LCM. If you consider exactly two numbers, then you will find that product of those numbers is equal to their HCF into their LCM. Make sure, children, this particular relation can be used to solve several problems on HCF and LCM, and this particular relation will go only for two numbers, right? That is, while you are considering two numbers, then only you will find this relation will be valid. Okay, it will not be valid for more than two numbers, because in those cases the HCF, the pairwise HCF, are not under consideration. Okay, so here we cannot count the prime factors exactly, and that is why this particular relation will not be valid for them unless until those numbers are exactly prime numbers, right? Now let's see how we can apply this relation for solving different problems. Let's first verify that whether this particular relation, that is product of two numbers, equals to the HCF and LCM, the product of HCF and LCM of them, is this particular relation is valid or not. Okay, let's take two numbers 20 and 25, and we have to first find out their HCF and their LCM. So let's do this. What is the HCF of 20 and 25? Let's follow the division process. So here we get, you all know this, 20, and this is HCF is equals to 5, right? What about the LCM? Let's use short division process for finding the LCM. 20, 25, hence we get 5 as a prime factor. So what is the LCM? This is 100. Okay. Now what is the product of them? HCF into LCM. What will it give? HCF is 5. LCM is 100. So this will give us 500. Okay. Now let's check the product of the numbers. What about the product of the numbers? This is 20 into 25. That is also 500. So look, while considering two numbers, we get product of the numbers equals to the HCF into LCM of the numbers. Hence the relation is very much valid for exactly two numbers. Now let's see one of the applications based on this particular relation. Suppose I have taken this problem. LCM and HCF of two numbers are 2175 and 145 respectively. If one number is 725, then we have to find out the other number. Now we know the relation between the HCF and LCM and the product of the numbers. So here we get that LCM of the numbers is 2175, and their HCF is 145. We also know that one of the two numbers is 725. And we have the relation. So the relation says product of two numbers is equals to their HCF into their LCM. So here we get 725 is one of the two numbers into the other number. This expression will give us the product of the numbers. This is equals to HCF means what? 145. LCM means what? It's already given 2175. So how will you find out the other number, students? Yes, this product will be divided by 725. Because here the problem is like this, 725 is in the product form, is multiplied with some unknown one, and the result of multiplication is 145 into 2175, that means 2175. So obviously to get this unknown number, we have to divide this product by this given number, right? So the other number equals to 145 into 2175 by 725. Hope it's clear. Now let's do the cancellation. This is 5, 4, 435, 145. They are getting cancelled. Therefore, the other number is 435. Thus, we can apply this particular relation between the product of two numbers and product of their HCF and LCM for solving several problems on the chapter Problems of HCF and LCM. Let's consider another problem on this chapter. The problem is, find the least number that must be subtracted from 5834 so that the result is divisible by 20, 28, 32 and 35. So here we have to find out that particular least number, what is to be subtracted from 5834. So 5834, 5834 is the given number, from which we have to find out the least number which is to be subtracted, so that the result of subtraction is completely divisible by these given numbers: 20, 28, 32 and 35. Okay, that means the required number, that means the number what will be, not exactly the required number, but the number what will be coming out after subtracting that required least number from 5834 will be, make sure my dear children, will be a multiple of the lowest common multiple, that is LCM, of these given numbers. Because we know by LCM of these given numbers we are getting the least number what is divisible by all these given numbers, right? So all other numbers which are divisible by 20, 28, 32, 35 should be the multiple of that LCM, because LCM is the least number which is divisible by 20, 28, 32, 35. So all other numbers should be the multiple of this LCM. Okay, so we have to just find out the LCM of these given numbers in order to get the least number divisible by these given numbers, and then we have to find out that how many times at most that LCM is going in 5834, right? So let's see how many times does it go. So first of all we have to find out the LCM of this numbers: 20, 28, 32 and 35, in order to get the least number which is divisible by all these given numbers as per the definition of LCM. So let's take, we are using short division method. So 10, 14, 16, 35, 2, 5, 7, 8. Then comes 5. Then comes 7. So what is the LCM? It is 2 into 2 into 5 into 7 into 8. That is 10, 20, 160. 160 into 7, that is 1120, right? So this is the least number which is divisible by all these four numbers. So all other numbers which are also divisible by this 20, 28, 32, 35 must be the multiple of 1120. So let's now check that in 5834, how many times does this 1120 go? So let's check this. We have to divide 5834 by 1120 in order to check it. So after division we get, I think it will go for 5 times. So it's 0, 5600. So 432. Make sure this 1120 will be repeated completely for 5 times in 5834, and after 5 repetitions 234 will be excess. I hope you all have understood that this 234 is the least number what is creating problem for 5834 to be completely divisible by 1120, right? So this is the least number to be subtracted. So the least number to be subtracted is 234. Hope the concept is clear. Let's take another application of HCF and LCM method. Here we have to find out the greatest number that divides 2300 and 3500 and leave remainders 32 and 56 respectively. That means we have to find out that greatest number which when divide 2300 leaves remainder 32 and which when divides 3500 leaves remainder 56. Okay? That means in order to find out the greatest number, which divides 2300 and 3500 to leave remainders 32 and 56 respectively, we have to first subtract 32 from 2300 and 56 from 3500. Why? Because these two remainders are creating problems for these numbers respectively to be completely divisible by that required number, that is by that greatest number. Okay, so in order to find out that greatest number which divides, means the greatest factor which divides this and this numbers to leave remainders 32, 56 respectively, we have to first subtract these two numbers from these two numbers respectively. Okay, so here 2300 minus 32 will give you 8. This is 62268, and 3500 minus 56 will give you 4434. 3444, and this is 2268. So if you find out the HCF of these two numbers, then obviously you'll be getting that greatest number which will divide this 2268 and 3444 completely. So in other words, when this greatest number, what will be found by the HCF of these two numbers, because HCF gives us the greatest common factor, greatest common divisor. Okay, then that particular greatest common divisor, when we'll divide 2300 and 3500, we'll leave the remainders 32 and 56 respectively. Okay, so let's find out the HCF of these numbers. So let's follow division process. This is 2268, 3444, 68, and this is 6711, 2268 again. This will go for one time. 2901 1176. You know the division process of finding HCF. So it will go for one time again. 1092 1092. This will give us 4 8 84. Again 1092. This is 84. 5 252. 3. So HCF is what? HCF is highest common factor of these two numbers is 84. Means when these two numbers will be divided by 84, it will leave no remainder. But at the same time, when these two numbers will be divided by 84, then 32 and 56 will be remainders respectively. So what is the required greatest number? So required greatest number is 84. Hope the concept clear to all of you. And this is the way of solving the problems based on the chapter HCF and LCM. Now, in your textbook, you will find so many applications on this topic. Try all of them. Hope this video will be helpful for all of you. Thank you so much. Take care. Stay safe. Bye.